Okay, let's talk about parametric equations class. No? So, ako yung isa akong parametric o partial differentiation. So, dali rin na siya. Okay. So, let's go to parametric equations. What are parametric equations? So, we've solved a lot of equations class. Kaya nga yung itsura no, x and y variables. Okay. And this is what you call the rectangular equation. Okay, rectangular equation. Now, if we introduce another variable class, which is variable t, we call it the parameter. And if we write x and y both as functions of t, we obtain what you call the parametric equation. Pero ang graph ana class will remain the same, no? Later makita na to, na nakatabulate ta, okay? So if this is your rectangular equation, we have here a parametric equation for x and parametric equation for y. Kung mag-set na dire ang mga values sa t, for example, t is equal to 1, we will get values of x and y, no? And we can plot it here. And that's the same with plotting or substituting these values sa x here, and we will get the same y. Okay, so basically, we can rewrite the rectangular to parametric and then parametric to rectangular. And we will see how it's relevant in getting the derivative of our equation. Okay, so what is parametric? Again, this is ang parametric equation class is a pair of functions x of t and y of t, okay, in which x and y coordinates are the output, okay, represented in terms of a third input parameter t. So basically, nag-introduce lang tao another variable t, no? Nga gi-write na to atong x and y in terms of that variable. Okay, suppose we have here a parametric equation class. We have x is equal to 2t and then y is equal to t squared. For t, from negative 2 to 2, no? So, itabilik na diri class, ang values sa atong t, we have negative 2, negative 1, 0, 1, 2. Okay, what are the values of y dayon? So, ato na siyang i-substitute diri for x and then for y diri. Okay? And then we will get these coordinates. If we plot that class, morning itsura sa ato ang graph, no? So, kining negative 4, 4, that would be negative 4, 4. Mali lagi negative lang. Ay, sakto day. Negative 4, 4. This will be this point. Negative 2, 1 kani nga point. 0, 0. 2, 1 kani. And then 4, 4 kana. Okay, so you will have these graphs. Okay, so kung gitagan ng parametric class, how do you convert it to your rectangular equation? This is the process now. So we eliminate the parameter. So if you eliminate the parameter, then we convert parametric to rectangular. Okay, first, if you have this parametric equation, to given ka ganina, we solve for t in one equation. So it could be t in terms of x or t in terms of y, but it's a bit easier if we express t in terms of x para ang atong final nga rectangular equation is naka-y in terms of x. Okay? So here, from this equation, x is equal to 2t. T na to class will be x over 2. And then, ato na din siya i-substitute 3. Okay, so we will get x over 2 squared. So that would be x squared over 4. Okay, mo na tong rectangular equation. So again, from parametric, we can convert it to rectangular. Okay, so mo na siya pag-convert class, pero ang pag-differentiate na to class, nasa tayo way to differentiate the parametric. But first, ato sa nang i-convert ang uban diri class. Para ma-practice lang mo. So we'll have x is equal to 2t minus 3 and then y is equal to 3t plus 1. So, that would be, again, ang t na to atong express into variable x. So here, no, we'll get transpose ang 3 So we will have 2t na lang sa isa ka side and then divided by 2. We will get this expression. And then substitute na diri sa ato ang y. Ang kining expression. So we will get y is equal to 3x plus 11 over 2. Okay, second one, we have x is equal to t cubed, y is equal to t squared over 2. So atong t diri class will be the cube root of x. Okay, and then kini ato na pong substitute dira. So this will be our answer. And then finally, we have t minus x is equal to t minus 3, y is equal to t over t minus 3. So atong t from this equation will be x plus 3. Substitute dire. Okay, x plus 3, x plus 3 minus 3. So simplifying, we have y is equal to x plus 3 over x. Okay, that's for converting parametric to rectangular, no? So let's see, how do we get the first derivative of our parametric equation? So if a smooth curve C is given with the equation, you have x is equal to f of t and y is equal to g of t, di ba? Muna itong parametric equation. And the slope of C, or sama ng slope, that is a derivative, no? At xy is, kung ano ta class itong dy over dx, no? And in this case, functions of t man itong x and y, then how do we get that if we have parametric equations? How do we get dy over dx? Not a way, no. One way is to convert parametric to rectangular and then get the derivative. Or kung nana kayo naka-parametric class, dali na kayo kay you have just have to get dy over dt over dx over dt. Okay, meaning you get the derivative of y with respect to t divided by the derivative of x with respect to t. Okay? Mura naman na nimong maka-cancel yapon ang dt over dt class, no? So that will leave us with dy over dx. Okay? Given that your dx over dt must not be equal to 0. Okay, again ha, there are two ways. Pero ang atong ipakita lang karon is how do we get the derivative of your equation rectangular using parametric. Okay, kabalo na mong ta kung saan pag kuha sa derivative using rectangular form. Okay, so okay, let's have an example. Calculate the derivative dy over dx with the following parametric equation. So first we have x of t squared minus 3, y of t 2t minus 1. Okay, so first is we get the pangitaon mo class ang derivative for each, no? Derivative ani with respect to t, derivative ani with respect to t. And then that would be dy over dt over dx over dt. Dili pwede mabalik, dili pwede ang x sa taas, no? So kana lang imong guide ang dy over dx. So dapat ang y ang nasa taas, okay? So y prime x prime of t, diretso na, no? This will be 2t derivative. Y prime of t, so kani siya derivative ana would be 2. So that would be dy over dx, that is dy over dt over dx over dt, or y prime over x prime. Okay, para mas dali ninyo manunduman. So that would be 2 over 2t, and that will be 1 over t. So ang atong dy over dx, ayan lang muka katingala, ma'am, nganong dili mo na siya x, no variable, t na siya. Kay of course, t man ang ato ang y prime o x prime. Okay? So, ang atong ma-final diya nga derivative is in terms of t. Pwede man gyapon nato kaon class ang value sa t no nga naka-x siya kung gikan ta diri. Pwede ra gyapon. Pero acceptable ang answer. Okay. Second one, 5 sin t mong x, y mo is 5 sin t. So, prime, get y prime. So, x prime will be 5 times negative sin t. That is negative 5 sin t. And then this one will be 5 cosine t. So divide lang y prime over x prime. The 5 cosine over negative 5 sine. That is negative cancel ang 5. Cosine over sine class will be cotangent. So easy na siya. Negative cotangent of t. Okay, that's for getting the derivative. Okay, napa siya pa-adri class. Calculate the derivative, okay, of the following parametric equation and then locate any critical points. So, i-locate na tong critical points. Now, critical points is katong, if you remember, that would be where the graph will have zero nga value sa iyahang derivative. Okay, or naka-undefined. Okay, but in this case, naka-polynomial man ta, so equate rin na to zero. And then, ang location sa atong critical points class is, again ha, naka-zero ang iyang derivative at that point. Pero if we locate the points, we need to get the coordinates. Unsay value sa x and unsay value sa y. Okay, so let's start with getting x prime and y prime. Okay, that will be the derivative man dy over dx. Okay, x prime will be from here, that will be 2. And then from here, y prime will be 3, t squared minus 3. Okay, follow na gyapon ta, dy over dx, that is y prime over x prime. So that is 3 t squared minus 3 ka na, all over 2. Okay, how do we get the critical points? Yung gyapon sa process, balag, process nito sa first derivative, balag, naka-t na siya class, dili na siya naka-x. Same process applies gyapon no nga. Atong i-equate ang numerator to 0 to get the values of t nga makapa-0 sa iyang derivative. Okay, so if we equate this to 0, pwede na to ni pagawas ang 3 dire, that will leave us with t squared minus 1, no? Is equal to 0, so makancel lang ng 3. That's why we have t squared minus 1. Okay, and then we will get the value of t nga plus minus 1, no? So meaning, kani nga mga values sa t ang makapa-0 sa imuhang derivative. Okay, these are the critical number, pero gipanguta naman critical points. So make sure nga point ang imong answer. How do we get the points, class? Of course, we already had a value of t here. So ato na siyang i-substitute to get the values of x and y. So if t is equal to 1, sorry, negative 1, ato ning input dira, ato sa ning input dira, so that will be kani yung value. So negative 1 ang x and y will be 6. So the coordinate class will be negative 1, 6. Okay, so kung ato nang i-graph dira, somewhere negative 1 na diring 6. So somewhere here. Okay, and then if t is equal to 1, substitute yapon, we get an x value of 3 and then a y value of 2. So the point will be 3, 2. So kung 3, 2, somewhere diri, no? Dira. Okay. Kung gusto mo makakita sa unsa itsura niya class, then you can convert this to rectangular form and then atong input sa Desmos. Okay. Let's have this problem. Find the equation of the tangent line to the curve defined by the equations. Parametric yapon, no? X is equal to t squared minus 3 and then y is equal to 2t minus 1 when t is equal to 2. So recall, how do we get the tangent line? Of course, we get the derivative lang sa daan. And then from there, we get the slope, which is the slope, that's also the slope of the tangent line. And then get the points nga asa mo pass through ang imuhang tangent line. And then mo na gamitin nato sa equation, okay? So, ato sa tauna, sa pagkuha sa derivative, that is x prime to be 2t, no, from here. And then y prime will be derivative ani, so 2. Okay, so dy over dx must be y prime over x prime, that is 2 over 2t, that is 1 over t. Now, ningon siya diri at t is equal to 2. This is very important kay dili pa man nimo ang value jud sa imong derivative. So we must input the value of t here. So at t is equal to 2, dy over dx must be 1/2. So mao din ni atong slope sa atong tangent line. Okay? Recall ang pagkuha sa tangent line equation, that is y minus y sub o is equal to m, which is the slope nga atong nakuha, multiplied by x minus x sub 0. Okay. So kanay siya class, mo na itong mga points, no? Mo ni ang point nga ni pass through ang imong tangent line. Mo na itong pangitaon. Unsa ito ni pagpangita? Of course, we already have the value of unsa atong gipangita nga point at t is equal to 2. So, i-substitute na nato diha class to get the values of x and y. So that is 2 squared minus 3. So 1 imong x. And then 2 times 2 minus 1, that is 3. So meaning, kani siya nga point, if we zoom that in, at t is equal to 2, ang xy ni mga coordinate is 1, 3. So diri di atong pangitaan og tangent line. Okay, that means, if we already have the slope nga 1/2, atong nang input diri sa m, so kani siya, pampulihan na itong value ani. Okay, x will be 1 and then y will be 3. Okay, And then simplifying everything, class, we will get a tangent line. Equation sa tangent line niya. Y is equal to x plus 5 over 2. Or kung ato na siyang expand gamay para makita na to, nara siya. Nara man din eh. X over 2 plus 5 over 2. So ang 5 over 2 na to, this will be our y-intercept. Okay? And then this kini 1/2 na to dire ato. Mao na siya ato ang slope. Okay? Kay y is equal to mx plus b man ang ato ang itsura sa tangent line. Actually, nibalik naman ni class. Pero application na siya sa parametric. Pero the idea is there itong pagkuha sa equation sa tangent line. Okay? Okay, for the second derivative class, up to the higher derivative, dali na kayo siya kay all you have to do is get the ang imong buhaton lagi class is from your first derivative, no? First derivative nimo. Kuon nimo kato imong nakuha nga first derivative, imo siyang i-differentiate na pod, okay, with respect to t. Unya divided by dx over dt. Okay? For the third derivative, second lang atong example later, pero para makita ninyo yung pattern, ang imong third derivative class, ato lang ning butangan og 2 diri. Okay? Dili ma-change ang imong denominator. Dx over dt gyapon na. Okay? Pagka fourth derivative, 3 na po na siya. And so on. Okay? So, kana lang always ang ato ang atong ma-change. Pero the idea is there. That is the derivative of your previous derivative. Okay? Divided by dx over dt. Okay, pero para makuan lang mo, para mas maanad lang mo gamay, second derivative lang tataman. Okay, let's calculate the second derivative for the plane curve defined by the parametric equation. So first, balik ko ng example na. So, ganina mo na itong example. Get the first derivative first. No? We have x prime, that is 2t, you can dire. And then y prime will be 2. Okay. So dy over dx will be y prime over x prime, that is 2 over 2t, that is 1 over t, or naka t to the negative 1. Ato siyang i-rewrite kay ato pa man ang kuan og derivative later. So the second derivative of y with respect to x will be, para sa kanina, kato mong first derivative, okay, you differentiate it with respect to t all over dx over dt. Okay, so ato na yung input diri class that kini here. Okay. And then this one, dx over dt. And so dx over dt, that is your x prime. X prime of t. Kana. Okay. 2t ra gyapon na sa ubos, then kana siya is t to the negative 1. So if we differentiate that with respect to t, that is negative t to the negative 2. And as is lang imong denominator. So the second derivative of y with respect to x in terms of t will be negative 1 over 2 t cubed. Okay, the second example, we have 2t plus 1. That is x prime. Kung na itong x prime na, that will be 2. And this one will be 3t squared minus 3. Okay. So this is our dy over dx, no, y prime divided by x prime. So kana siya divided by ana. Okay. And then again, to get the second derivative, imura ni siyang i-differentiate with respect to t sa taas, inyang ubos, your x prime. Okay, so 2. Okay, differentiate this one. Pwede man siya mabulag class, no? Ato ning bulagon para mas inyo. This will be 3t squared over 2 minus 3 halves, di ba? So if you differentiate that, ma-zero naman siya. Okay? So kani siya mahitabuan is 3 halves over derivative of t squared, that is 2t. Okay, all over 2. So if you okay. So if you simplify, makancel man imong 2 diri, no, kani siya. So that leaves us with 3t over 2. Ang second derivative sa imuhang y with respect to x. Okay, so that's all for parametric equations. You can go back sa video kung naman na nalibugan, but I'll proceed na to the partial differentiation. Ako na lang bulago ng video class ha kay sakit na sa tutunan.